All right. So welcome to this session, and here we'll be talking about logical operators. Now we're just from seeing relational operators, right? And we saw that relational operators will compare two data types, all right, to give you a Boolean value that will tell you whether the comparison was true or false, all right? Now logical operators, on the other hand, will compare two relational operators, let me put it like that, or two results from relational operators, which means logical operators compare booleans, all right. Mainly it wants to know if the first comparison and the second comparison are true, for example. So let me give a practical example so that you get me very clearly. So now we are able to know whether maybe a certain variable x is greater than 2, right? Using relational operators, or if it is equal to 2. But can we know if a certain variable x, for example, is in a range of numbers? Can we know whether it is between 2 and 3 at the same time? For example, is that possible? No, right? That is where logical operators come in. Why? Because if I have to know whether x is between 2 and 3, for example, I need to make sure that x is greater than 2, and at the same time, x is less than 3. All right? So the statement I've just made can be written in MATLAB via the help of logical operators. So there are fundamentally two of them that we shall see. The first one is the AND operator. All right, so we shall see and what is used to represent AND in MATLAB is the double ampersand. All right, that particular symbol you're seeing on the screen there. All right, it stands for AND. Okay, so let's just apply this and then we'll see the next one. All right, so let's use our example. I have a certain variable x. Okay, let's give the value of x to be maybe 1.5. We know that 1.5 will be between 2 and 3. All right, no, that's wrong. 2.5. Okay, we know that 2.5 will be between 2 and 3. All right, so now I want to check. What will I say? I will simply say x, right, will have to be less than, let's include 2, less than or equal to, sorry, greater than or equal to 2. All right, and x will have to be less than, and let's include the 3, or equals to 3. All right, so remember here I've just created a variable x, okay, just to be able to write this statement right here. But this will check whether x satisfies this operate or this comparison here and this comparison here simultaneously. All right, so is x greater than or equal to 2 and less than or equal to 3? That's what this statement means here. Is x greater than or equals to 2, or and less than or equals to 3. All right, so in this case, if I press enter, obviously because x is 2.5, the answer will be 1. All right, but let's change the value of x, and let's say x is equal to 4, for example. We know that 4 is out of that. All right, so if I run that same operation, what happens? The answer is 0, right? Because x does not satisfy this other condition right here. All right, so here we have a first condition and we have a second condition, and we want to know whether those two conditions are satisfied simultaneously, so one and the other, and this is the logical operator that we use. All right, so in a certain case, in another case rather, we want to know whether one of the conditions is being satisfied. So is x greater than or equals to 2, or less than or equals to 3? Okay, so that or word is the key here. All right, and that or word gives us our next logical operator, which is none other than this double straight sticks here, right? So this is what will stand for or. All right, so if I want to write and say x greater than or equals to 2, or, all right, now I want to know, according to you, in this case, will it be true or will it be false? Well, I guess it will be true, right? Because even though x is equal to 4 in this case, and it is less it is not less than 3, all right? It is, however, greater than 2, all right? And we have said all is English language, all right? One condition or the other implies that not both must be satisfied. One of them being satisfied is sufficient, all right? So this should be true because x is equals to 4. Okay, so basically that's that, and you can make this as complex as you can. All right, you can write a very long expression on this. So if I create, for example, another variable y is equals to 3, all right, I may want to know if x is that, okay, and so I want to make sure that this is first satisfied, okay, and if it is satisfied, then compare it also and y, okay, maybe less than 2. All right, so what does this tell me? It tells me if, okay, make sure that x is greater than or equals to 2 or x is less than 3. So you first of all check this particular condition here, this particular long expression here, give the results, okay, because I've put brackets here, and then that result, it will come and check and y less than 2. So this will be a Boolean result right here, and you will compare it with this other Boolean result. What do you think will be the outcome? We've already checked for this one, and we've seen that the outcome here is 1, right? This is true because x is greater than or equals to 2. But now, true and this y here, what is it? Is false, right? Because 3 is not less than 2. So true and false, what does it give us? Obviously, it gives us false, right? Because when we say and, it means that the two conditions have to be satisfied. Okay? So the answer there will be 0. So this is simple, all right? It is simple English language, and I've prepared a little table for you just to show you how these things operate with each other. Okay, so we have it right here. So it's simple English language, all right? If I say this condition and this other condition have to be satisfied for this to happen, it means that the two conditions have to be satisfied compulsorily. All right, so we are here on the and first. Okay, so we have condition 1, condition 2, and what will be the result? If condition 1 and condition 2 are true, then obviously the result will be true. All right, if condition 1 is true and condition 2 is false, the result will be false. Oh, because when we say and, it is English language, guys. I don't know. I don't. It's English. It's logic. All right. If one, you get the point. Hmm. All right. So I was saying, if one is true and one is false, then the result will be false. All right, because and implies that the two conditions have to be true before everything. One is false, one is true, the two are false, the result will be false. So the only case where an and comparison can be true is when the two conditions that are being compared are true. In the case of or, right, or implies one or the other have to be true for them to be true. If the two are true, it will be true, obviously, because after all, one is true. If one is true and the other one is false, the final answer will be true. If one is false and the other one is true, the other answer will be true. And then if the two are false, that's the only case when or is false. All right. So I hope that all of this makes sense. Don't worry, we'll have a lot of practical examples for you to feel comfortable around this. But basically, that's that. All right, that's that. And I think this will close our discussion. No, not yet. All right. So we'll have a special section to talk about immediately after this. We'll have to see some MATLAB built-in functions that are very useful when it comes to these logical statements that can be very handy. And then from there we'll move on to a whole new section which I'm very excited about, the MATLAB editor. All right. So see you in the next one.